Okay, now that we know some of the characteristics of a parallelogram, we're going to use those concepts to help us find missing values. Okay, so we're looking at a parallelogram here. This is quadrilateral PQRS. Okay, remember we can name that quadrilateral a lot of different ways, but we start with one corner and we go around the figure. We can see that the measurements are not given to us as numbers, but as expressions. And so the first question is, what is the value of x? Well, one of the properties that I know about quadrilaterals is that their opposite sides are congruent to each other. So when I look at this, these two sides are opposite of each other. They're going to be congruent to each other. So I can set up an equation. I can say 7x minus 3 is equal to 2x plus 12. And I can solve that equation. I also could have set, since these two opposite sides are congruent to each other, I also could have set those equal to each other and solved. I should get the same value for x. If I solve this, I'm going to subtract 2x from both sides to start. X's are on different sides of the equal sign, so I've got to subtract 2x from both sides. So I would have 5x minus 3 is equal to 12. Okay, my next step would be to add 3 to both sides. So I would get 5x is equal to 15. And if I divide both sides by 5, x equals 3. So my value of x is going to be 3. It says, what is the length of q to r then? So if up here, here's q to r. What is that length? Well, I have to take my x value and I have to plug it in up here. So I would say 7 times 3 minus 3. 7 times 3 is 21 minus 3. That has a length of 18. And again, that's not an angle measure. That's not degrees. That's a length of side. So it's 18 units. What would the distance of r to s be? Okay, well, rs would be this side of the parallelogram. Okay, so I'm going to use that same value of x that I found, and I'm going to plug it in here. And I would say 5 times 3 minus 3. 5 times 3 is 15 minus 3. I get a distance of 12 for that side. And if we plug in our x values over here, since these sides are congruent, QP would be 12 as well. And since these two sides are congruent, PS would be 18. Okay, you can check that out if you don't trust me on that. Okay, next question, next set of questions. It says we have a parallelogram here. We have parallelogram ABCD. Okay, we're given an angle measure down here that's 114 degrees. Okay, it says what are the measures of angle A and angle C? And then what is the measure of angle B? So they want the other three angles in the parallelogram. Well, one thing that I know about a parallelogram is that, what do we know about opposite angles in a parallelogram? Okay, they're congruent to each other. So I know that the measure of angle B is going to be 114 degrees. That's an easy one. There's really nothing to calculate there. Now, finding A and C are going to be equal to each other as well, but I don't know what either one of them is. So the other thing we talked about the angles of a parallelogram, what did we say about the consecutive angles, the ones that were side by side in the figure? Yeah, we said they were supplementary. They add up to 180. So the measure of A plus 114 has to equal 180. So if I take 180 and I subtract 114, okay, that's going to equal 66 degrees. Okay, so the measure of angle A is going to be 66 degrees. Okay, that's 66. Oops. Okay, well, what's opposite? What do we know about opposite angles? Well, they're equal. So C is also going to be 66 degrees. Okay, the next figure, it says use parallelogram RSTU. SU, so this distance all the way across is 35. That whole thing is 35 units. From K to T is 19. I'm going to come back to that. It says, what is SK? Okay, well, SK is just this portion of it. Well, what did we say about the diagonals of a parallelogram? One of the properties was the diagonals do what? They bisect each other. So this would be half, if it's bisect, it's half of what 35 is. Half of 35 is 17.5. Okay, if KT, the distance from K to T, is 19, then what's the distance, what's the total distance across? Well, both of these are going to be 19. This distance is going to be 19, so if I add them together, I get a total of 38. Okay, we know that the diagonals bisect each other. Okay, and that's what we have. There's other different properties you have. I'll just give you the heads up on your worksheet because we know that parallelograms have parallel sides, just like the trapezoid. Because we have a set of parallel sides, we actually have two sets here. You need to be thinking about those relationships of alternate interior angles, same side interior angles, maybe even corresponding angles. You need to think about those relationships because you're going to see those relationships appear again just like you did with the trapezoid because we have parallel lines. Okay, so give that some thought as well, and you're going to tackle the next worksheet.